Hello, we're the Wireless Communications Enterprise. We're going to be talking a bit about enterprise as a whole and what our different projects are. So for what enterprise is, in order to graduate, Michigan Tech engineering students need to do a senior design uh, part of their degree in the last year. As an alternative to that, they can do enterprise. And so that's kind of what the enterprise program is about, is having students do different engineering projects to get kind of an idea of what the role would be like, or different ways of working in a team for projects. For WCE in specific, we are an enterprise in the ECE department, open to all majors. We have a focus on technology development. So our full title is Wireless Communication Enterprise, but we're not limited to just wireless communications. We're a bit more broad than that. Well, we work on projects that come in externally from industry, so sponsored projects, whether that be from Ford or ArcelorMittal or other teams, or internally, like some of our students have their own neat ideas they'd like to try out, whether it be about soundboards or display pieces for the enterprise. So these projects are assigned to smaller teams of students who develop their projects over the semester. We have weekly meetings and updates, and we make sure that everyone in the enterprise at large is kind of on board with what's going on, but also there's still that smaller dedicated team that's furthering the project. So here we'll go through some of our projects, or we'll go through all the projects we're working on, and at the end we'll go through a bit more of them in depth. So first is the LED fan project. The reason we have this project this semester is because for years WC has had this like spinning light carnival game that we display whenever we go anywhere to talk about enterprise or Michigan Tech. So people will hit a button on a box and you try to stop a light traveling around a circle at the top, and then it all flashes and it's all pretty like a carnival game. So that display has gotten kind of broken over the years. It slowly is maintained less and less well, just over time. So what we would like, or what this project is about, is making another display piece similar to that. So this display piece is, if you've ever seen those like LED clock fans where you have LED strips on a fan blade that spin around really fast and you can display different things, we're trying to make a very modular, very easy to change LED fan that can be used to bring to campus and just display whatever game we might want at the time. The ArcelorMittal team is one of the sponsored projects we have. ArcelorMittal has is primarily a steel manufacturing company, and so in their production part of it, they have manufacturing lines and everything that runs through, and they have a lot of equipment and ways to test that everything is up to spec and up to standard based on what they want. So one of our students previously had an internship with ArcelorMittal, and what he was working on there, they decided to let him continue to work on here, but for enterprise instead of as a job over the summer. And so that's working with keeping consistent quality of parts by managing data coming back from all the sensors on the line, and then figuring out ways to reliably fix all those different parts.
Little Brothers Friends of the Elderly is a charity organization that focuses on helping to relieve older people from social isolation. They have an Upper Peninsula chapter with a website that helps volunteers help the elderly. WCE helped them with their website a few years ago, and now they want some more changes and some things fixed. What we're doing to help them is to implement these changes and then make it easy for them to implement changes on their own without us in the future. The IT Oxygen Enterprise is helping us in this by providing help with different website testing environments. The Bluetooth speaker team. We know Bluetooth speakers are a common commodity, but what goes into making one? The goal of this group was to make a speaker with a built-in LED visualizer. So kind of like how you see on an equalizer for your home stereo. We wanted to create something like that built into the speaker. This is a first-year project for people new to the enterprise because simply you could buy a Bluetooth module that includes amplifiers. You can find them on the market and just use wires to hook it to a speaker and a power supply. But the goal of this is to not rely on these components and to design them yourself. This project gives an array of focus areas from development in hardware and software, and even acoustics with the design of the speaker housing to provide as balanced a response as possible, making this a great entry point for a lot of newcoming members. Our Sweet Sound team is in the process of developing a digital signal processor, DSP for short, for audio applications. The idea arose from the transducer theory class, where students can use any means necessary to achieve a flat response from a speaker. By this, we mean that every frequency within the audible spectrum receives the same gain. Think about using an equalizer on your stereo, trying to get the truest possible sound to what was actually recorded. Many students opt to buy a DSP for this class, but these are very expensive, even the budget level ones. So the goal was to design our own. Given that the processor chip is only $25, a cheap alternative seemed reasonable. On the hardware end, picking other components like an analog to digital converter or a digital to analog converter to get the signals to and from the processor, and also op amps for active high pass filtering is necessary. And it also gives the opportunity to design a PCB. To expedite software development, a development board was ordered to give a complete environment to work through. This allows for using jumpers to other components to validate design and component choices. For instance, this allows us to test multiple ADCs and DACs to validate which has better frequency response.
The final project we'd like to talk about in depth today is another student pitch project. The Intelligent Microgrid project was pitched by a student who had recently traveled to Haiti to help aid in the recovery. During their trip, they happened to notice that the power situation in Haiti was really poor, with power sometimes only coming on for a few hours a day. With this inspiration, the student came back to Enterprise and pitched the idea of producing a portable power production and storage system. From there, the team decided that the device could maybe be beneficial in many other areas as well, where power might not be as consistent, such as certain residencies and recreational vehicles, at construction sites, as well as places affected by natural disaster. One of the big ideas is that this system should be able to consult itself about what kind of upgrades it wants to make. By this, we're talking about things like getting a bigger battery cell or upgrading its input power. To do that, it needs to do things such as track its battery temperature, see what its input and output is, track the environment to see things like the humidity, the wind, and the temperature, and use all of these components to determine decisions that can help make it more efficient and safer for the user. The main idea behind its design, though, is to find the most efficient solution for a microgrid application. To accompany the device, we have started developing a user interface for which the system analysis can be observed. This program has undergone a few revisions after usability testing, and its current state can be seen here. It features a simple and easy to navigate interface and a basic terminal window to display system messages and errors. To the right of this is the location for which the system-specific information can be updated. Currently, this is limited only to the size of the battery itself, but in future revisions, it will support every major aspect of the device, including things like battery storage, power input, power output, along with any other characteristic that we think the user might want to be able to manipulate. Though this project is new and still in very early stages of its development, it's being run by a younger team of engineers who plan to continue the development and show promising results for the future of this project. We'd also want to make a special mention about a few of our sponsor projects. This semester, we currently have 3 sponsored projects which are under non-disclosure agreements. As such, we wanted to talk about them very briefly as to respect the nature of those agreements. We currently have a team of engineers working on a project for Whirlpool, which involves students running various usability tests and running some analysis on some new technology for Whirlpool. It has been a great project for these engineers. They've been able to do some really interesting research into some unique and up-and-coming technology. We also have 2 other projects sponsored by the Ford Motor Company. Ford has been a continuing sponsor and the source of many projects for WCE for many years. Recently, they have funded 2 new projects which revolve primarily around creating simulations to prove the effectiveness and viability of some potential future Ford products. All these teams have been working closely with their sponsors to produce some really intriguing results, and we look forward to the exciting things yet to come from them. To wrap things up, we'd just like to say a quick thank you to all of our generous sponsors, namely ArcelorMittal, Little Brothers Friends of the Elderly, Whirlpool, and the Ford Motor Company. And that will conclude our presentation. Thank you all for watching, and have a nice day.